This video is going to cover the topic of translating expressions and equations. Be sure the date and topic are at the top of your page. The essential question for the video is, how do we interpret and translate situations as algebraic expressions? And we've been working with expressions for a while now, and can seem pretty abstract. I know people think, why do we need to know about this? What's the point? Well, expressions and equations can help us think about problems. And we should start with a few key words and phrases. This is going to be a short list, and there are many other words and contexts that we will practice and come across as we work with this. But the idea is that when we're thinking about the context of a story, some of these words will tell us that we might need to add, subtract, multiply, divide, or that it's telling us that it is equal to something and therefore it is an equation. I'm going to just jot my list down. I want you to jot the same. But of course, like I said, there could be and are many more ideas that we could add to this list. So make sure you have these down. If you think of others that you would like to share, feel free to do so. And of course, we can always add to this list as we come across more examples if it helps. But let's look at some examples. We're going to start with a really basic one that just has one thing happening with it. So I've written here, which is true, that I am 5 years younger than my sister Catherine. Without knowing how old either of us are, we can use an expression to represent this. Since her name is Catherine, I'm going to use a K as my variable to represent her age. So I have K here. And I know that I've told you that I'm 5 years younger than her. So if I think about what that's telling me, it's that I take her age and I simply show that I need to subtract 5, right? That's my whole expression. And then once you know her age, you can substitute that in. Say her age is 20. You would subtract 5 from that once you've substituted that in and find my age, calculate my age, right? Pretty quick. Here's another quick one. The length of a soccer field is 30 yards more than the width. So we want to write an expression to represent that. This presumes that we're starting with the width, right? That's what we are basing it off of. So I'm going to use the letter W. And we know that the soccer field has a length that is 30 yards more than that. So this is telling me that I'm adding 30 on to the width to represent the length. So I'd take the width and I'd say, oh, with 30 extra yards, this would be the expression that shows the length. But of course, not all the expressions that we need to represent are quite so quick, right? Sometimes they have more than one thing going on. We're not just adding one part or subtracting one part. So let's take a look at a couple of those next. Let's say, for example, that I have some string, and I don't know how long it is, or you don't know how long it is, but you do know how much it is in relation to someone else. So it says that my string is 3 more than 2 times my neighbor's string. So whatever her length is, mine is 3 more than twice her length. So I'm going to think about a way to express this with an algebraic expression. And since we're talking about string, that's going to kind of guide me with my variable. I'm going to use the letter S, try to make not look like a 5 here. And I know that whatever my neighbor's string is, I have to add 3 to that. Right? But I'm not just adding 3 to the string, I'm adding 3 to 2 times the string. So I also need to put a coefficient here to say that I have the S twice. Her string twice, and plus 3 more is going to be the length of my string. Now that's all I'm going to write for now, right? 2s plus 3 is the expression that matches this. Once I know what the length is, I can substitute that in and then I can figure out my length. But for the purposes of this activity, all we want to do is make sure that we can take those words and turn it into this expression. In our next example, we have a rectangle, and I have written here that the length is 4 more inches, feet, whatever it is, than the width. Let's just go with feet. So we have to write an expression for the perimeter of the entire rectangle. So we can write this as an expression. That's going to be totally fine, but I'm going to draw a picture first. And I know that my starting point is that I'm comparing the length to the width. So I'm going to use W for my width. And I know that if we do W plus 4, that would be the length. So I'm trying to find an expression for the perimeter. And the perimeter is what happens if we add up all 4 sides. And of course, I'm just going to fill in what I would know here. Both of these sides across would be identical, and as would these be. So if I'm trying to write the expression, then I can say I need to add the W plus the W plus 4 plus another W plus the last W plus 4, right? Adding up all the sides with the variables that I have here. And then I would just combine my like terms. So I have a whole bunch of W's that I can add together to make 4W. And I have a whole bunch of 4's, constants here, that I can add together as well to make 8. So this would be my expression. But if someone told me what my total was, I could even turn this into an equation. This would be telling me, let's say the perimeter of the rectangle is 28. This would be telling me that this is an equation. I know the total amount. So I'd be able to say, oh, that expression of 4W plus 8 is equal to 28. And then, as you'll see later on this week, and going into the future, that we will work to practice to solve equations like this so we can figure out what the width and length would actually be. In this one, we see that Curtis bought skins on Fortnite for $10 each. He also spent $20 on exactly one dance. So if we want to talk about this as an expression, what we know is that there's a certain amount that he's spending on each skin, but we don't know how many he bought. So that's going to be the variable that we're talking about. So again, I'll use S here carefully. So I have S, and we don't know how many skins he bought, but we know that he has to spend $10 on each of them. So I know that I'm going to use $10, right, to represent the $10 he's spending for each skin. But then, in addition, he also spent exactly $20 on one dance. So I'm going to add that to his bill, right? That doesn't change. That's a constant, right? So that's going to just be at the end of our expression. So we know that if we wanted to write an expression to show how much Curtis spent, we would say 10S plus 20. If we then find out the actual amount Curtis spent, then this would actually be able to be written as an equation instead of just an expression, right? So we know that his total was $80, right? This is creating a full equation. So I know that 10S, his $10 for each skin, plus his $20 on his dance was a total of $80. And I would be able to write this as an equation. And from there, we can work out to find exactly how many skins he purchased, right? How much that S would be valued, how many skins he was able to buy. And that's something we're going to add on to more as we work more with our algebraic unit. But this video was meant to just sort of introduce you to the fact that we need to be able to interpret and translate word situations or real life situations as algebraic expressions and sometimes as equations. So make sure you have your notes, bring any questions you might have to class.